Hi friends, welcome to my first session of the actual course. This is immediately after the introductory video that I put up yesterday. So let's begin with the concept of resolution of forces. So I'll be going a bit fast and we'll be breaking up the videos into small around 10 to 12 minute videos, so it's easy for you to grasp. Now this is a very basic concept. Those of you who already know how forces resolute along the x and y components, you can skip this and go to my next video, which will be on deriving the parallelogram law of the force resolutions. So without any further delay, let's understand what basic force resolution is. Let me give you an example. Let us assume there is a brick here, okay, and it has a weight, right? Let us assume that it has a weight of, say, 1 kg. Okay, let's not use 1 kg. Let's say it's exerting a force of 10 newtons. It is exerting a force of 10 newtons on the ground. This is the ground. And because it is exerting a force of 10 newtons, the normal reaction here, which is normal, this is also equal to 10 newtons. All fair here. Now the brick is stationary because the forces are in equilibrium. 10 newtons downwards and normal force. So both of this force and this force cancel out. So therefore it is stationary. Now let us assume that we pull this rope in this direction with a force of, let's say F. We'll just call it as force of F newtons. Okay. Now what happens to the normal reaction? Tell me. Now if this is being pulled, if this brick is being pulled by a force F, two things are going to happen, right? Can you tell me what they are? One is, for the time being, we'll assume that this particular ground is frictionless. Okay, this is frictionless. This is frictionless. So as soon as a force is applied, what will happen is the brick will start moving in this direction. Am I right? The bricks will start moving in this direction. And what will happen to the normal reaction? The normal reaction also, which is initially 10 newtons, the weight exerted by the brick, which is of 10 newtons force downwards, the normal reaction, which is 10 newton, will no more remain 10. What will happen? It will decrease. Why? Because this force will also have a component in this direction also, right? So this force has two components. One is in this direction, which is the xf, we can call it as fx, and this will be the fy. And if this is the angle theta made, then what is fx? Fx will be equal to f cos theta, and fy will be equal to f sin theta. And what will be the new weight now? The new weight or the normal reaction now will be equal to 10 minus f sin theta. Am I right? And what will be the force? Along the x? It will be equal to f cos theta. So please understand this basic concept. This is very important because we will be using this concept for solving or deriving our parallelogram law of force resolutions. Let us take another example of resolution of forces. Let us assume that there is an object here, okay, and it is acted upon by two forces. One force here, we'll call it as F1, and there's another force here, which is F2. Now, because there are two forces, what will happen is and if you see, these forces they're not balanced, because you see there is this force is in along the x-axis, and the second force is along the y-axis. And if you basically see it, these forces do not seem to be balanced. If there was another force here and another force here, then in that case, if there was another, so let me just draw it this way. If there was another force here, let's say F3, and another force here as F4, and if F2 was equal to F3 and if F1 was equal to F4, then this particular object would have been stationary. But in our case, that is not what it is, because we don't have these forces. We only have F1 and F2. Let me draw this again. So this is our body. Now, if I ask you a very fundamental question, what will happen if I apply this force here, F1 and F2 here? What will happen to this body? In which direction will it move? Obviously, your answer will be, it will move in this direction. Now, how are you able to tell this? It is by common sense and by visualization and common sense, right? By using visualization and common sense, you are able to tell me that this particular force, the effect of these two forces, F1 and F2, will result in the object moving in this direction with a force. We'll call it as Fr, right? This is R is the resultant force. So in effect, what we are trying to understand is, when two or more forces, maybe there is another force, let us say there can be another force that is acting in this direction. Let us call it as F3. Or there can be another force acting in this direction, let's say, we'll draw it, let us say in this direction. Let's say somewhere in this direction. Let us call it as F4. So now you see we have F1, we have F1, we have F2, we have F3, and we have F4. So if you see, all these forces are now acting on this body. Now, generally when we solve problems in physics, we try to simplify things so that the treatment, so that we are able to apply a lot of mathematical formulas and procedures to the problem. So when you simplify this, now suppose I have to work with all these four forces, it becomes very difficult to understand the dynamics, like what is going to happen to the object. But if I'm able to convert all this, so if I'm able to take all this and resolute the forces, I get one single force, and that is the resultant force. So I don't know now how these forces will act, but let us say that all the forces effectively, if you actually solve all the forces, maybe we will have a resultant which will lie somewhere, maybe let us say in this direction. Let us say maybe we'll have a force lying in this direction. We'll call it as Fr. Now this is the whole philosophy of resolution of forces. The whole idea of resolution. The whole idea of resolution is taking several forces and converting them into one resultant force. And there are primarily two ways to do it. So one is called the parallelogram law. The second one is called the triangular law of vector addition. Now we will extensively, I'll be doing two separate videos, one on the parallelogram law and another one on the triangular law. Now, what these laws basically will tell you is, if you have several vectors, if you have n number of vectors in different directions, how you can use various techniques and mathematical formulas and applications and trigonometry to find a resultant for these. So that's the basic concept. Now, I'll in my next video I'll be covering the parallelogram law, where we will derive the basic formula and understand its application. And in the subsequent video, we'll understand what triangular law is. So I'll see you in the next class. Thank you. Bye.